Hi everyone, welcome to today's lesson. Today we are going to cover geometry of straight lines. I'll only be doing part 1 today. Part 2 with parallel lines will be covered in another video. This is a chapter in the grade 8 CAP syllabus. Let's start off with the angles on a straight line. Here are two diagrams that are drawn to scale. This means when we measure the sides with rulers and we measure the angles with a protractor, we are going to get realistic values. Often in tests and exams, diagrams are not to scale. Nevertheless, in this example, let's investigate what the value is of the two angles on the straight line. The first angle, when we place it on the straight line, we're going to measure it from 0 until where this line is. And we get to a value of 50 degrees. So angle 1 is 50 degrees. Now on the other side of this common side, the adjacent angle, we will measure that, angle 2. And we are going to now start measuring from 0 on this side, all the way to 130. This means angle 2 is 130 degrees. Therefore, angle 1 plus angle 2 give us the sum to 180 degrees. What enabled us to do this calculation? Angles on a straight line. That is the reason that we are going to use when we work with the angles on a straight line. Another example, I've already calculated and measured the angles. Angle 3, 79 degrees, angle 4, 69, and angle 5 is 32 degrees. Once again, we can see that the sum of the angles on the straight line is equal to 180 degrees. So this is very important. On all of our straight lines, the sum of the angles equals 180 degrees. So the two reasons that we use when working in these kinds of scenarios, angles on a straight line and adjacent supplementary angles. This means angles that are next to each other add up to 180 degrees. Okay, the next piece of theory that we're going to move on to today are these three examples. They are very popular and are incorporated into bigger sketches. The first one is this special angle over here. We see it in Pythagoras and other geometry. This is called a right angle, and the value of a right angle is 90 degrees. What we can see is 90 is half of 180, which means that a right angle's value is half the value of a straight line. So the reason that enables us to work with other angles on a straight line where there's a 90 degree involved is adjacent complementary angles. Complementary means adds up to 90. So if there were angles inside of this 90 degrees, those combined would make complementary angles. However, on the straight line, it would add up to 180, which is a supplementary angle. The next one is angles in a revolution or angles around a point. The sum of the angles around a point is 360 degrees. This is evidenced by if angles on a straight line is 180, if we double that, we're going to get to 360 degrees. And then the last thing is vertically opposite angles. This means angles which are created by two straight lines which intersect. Those two angles will be the same. And that is the theory of today. Now we're going to cover a couple of examples just to put this theory into practice. Feel free to take a screenshot of the theory and copy it into your books. Okay. So the example. Calculate the size of A, B, K, L, F, X, Z, and Z. So they are telling us that we need to find the value of those variables in the various situations. The first one, we have a sketch with A and 64 degrees. How do we calculate the value of A? Well, we know that angles on a straight line equals 180 degrees. That means A plus 64 equals 180 degrees. And our reason that we can make that statement, it is angles on a straight line. Now we need to isolate our variable by taking our 64 over to the opposite side. Basically, subtracting 64 on both sides. We are left with a value of A to be 116 degrees. If we substitute that in just to test, 160 plus 64 gives us 180 degrees. So we know that we are correct because it is angles on a straight line. Okay, the next example. We have a 90-degree angle, 21 degrees, and B. We need to find the value of B. What do we know? This is angles on a straight line. So we can say B over here plus the 90 degrees plus the 21 would equal 180 degrees. How are we able to do that? Because of angles on a straight line. Once again, we need to isolate B. So we'd say 180 minus 90 minus 21, and that's 69. Alternatively, you can also isolate the sketch just to that point, because what did we learn in the previous section? Adjacent complementary angles. So we know that this one side is 90 degrees. This side would also then be 90 degrees. So 21 plus B would equal 90 degrees because both sides are 90 degrees. Therefore, if we isolate B, we also get 69 degrees. Our reason for this method is adjacent complementary angles. Now, what's important to note is there are many different ways that you can get to your answer. With geometry, you're on your own personal journey as long as your statements and your reasons make sense. Okay, now we're going to move on to the last few examples. This is where it gets a little bit tricky, and a lot of students panic when they see these kinds of examples. But hopefully, I can explain it in a way that's easy and understandable. Example 3. We are given a sketch with two straight lines that intersect. We have 66 degrees on the one side and 3k plus 12 on the other side. Find the value of k. So what we learned in this scenario over here, vertically opposite angles. If star is equal to star and circle is equal to circle, then surely 66 would equal 3k plus 12. Why can we deduce that? Because they are vertically opposite angles. They are perfectly opposite, right? Next to each other when they are opposite, right? Next, we need to get onto our reasoning, our mathematical reasoning. So we have stated that 3k plus 12 equals 66. Now we need to isolate k. How do we do that? We need to carry over the plus 12 and it will become a minus 12 when we subtract 12 on both sides. Then we are left with 3k is equal to 54 degrees. To get k on its own, we need to divide both sides by 3 because that is the common factor. And that will enable us to get k on its own. We have k is equal to 18. When we substitute that into this, we'll see that we get 66 degrees on both sides. The next example, the reason I've included this is because there's more than once that a variable is used, and there is the set of drawn lines. This drawn lines means that this angle underneath the lines is equal to this angle because there's the same set of lines. What do? We can say 2m plus 2m. This means that the value underneath this two lines is also 2m. 2m plus m plus 65 equals 180 degrees. Stating our reason, it is the angles on a straight line that enabled us to make that statement. We need to isolate m. So once we've carried over all of our numbers and we are left with m's on the one side and numbers on the other sides, we divide both by that common factor that will enable us to get m on its own, and we get m is to be 23. The last two examples that we're going to move on to. Example 5. Once again, we see 2x minus 55, 3x, and 70. We need to state that all these three angles equals to 180 degrees because we are working with the angles on a straight line. So you include your reason, angles on a straight line. Now you add your like terms, 2x plus 3x is 5x, negative 55 plus 70 gives us 15. Get your variables on one side, your numbers on the other side, and isolate x. Then the last example, I've incorporated two variables. We have 105, y, and z. Now, there are two ways we can work this around, but ideally, you should try and work it in a systematic way, so I'm going to do it in alphabetical order. So, I'm going to start off by working out y. I'm going to isolate that part of the sketch, and I can see I have a straight line. So y and 105, when we add them, we'll get 180 degrees because angles on a straight line. You would get the same answer if you isolated the other half of the sketch. Z would be 75 degrees. Now let's suppose we've only worked with the y to be 75. How are we going to find the value of z? Instead of working out angles on a straight line on the opposite side, we can just say that z is also equal to 75 because y is equal to 75. They are vertically opposite angles. Referring back to the diagram, vertically opposite angles. Same in this scenario. So I hope that made sense. I know it's a lot to take in, but if you practice, do a couple of examples in your book, it will become a lot more understandable. Be sure to give this video a thumbs up, subscribe to my channel, and let me know what sections you would like me to cover in the next video. Thank you so much. Bye.